Welcome to this video lesson on the LM741 operational amplifier. This is one of the most widely used components in analog electronics, and in this session we're gonna talk about the critical performance parameters of the LM741 that define how this device operates and what you can expect in real-world applications. Before we dive into the specifics, let's start with a brief overview of what an operational amplifier or op-amp actually is. An op-amp is a high-gain voltage amplifier with differential inputs and usually a single-ended output. It is designed to amplify the difference between two input voltage while rejecting any signals that are common to both inputs. The LM741 is one of the classic op-amps known for its versatility, making it a staple in many analog circuits.
Okay, so now I'm going to talk you about what is an offset. An offset is a small voltage difference between the inputs of the amplifier when no signal's input lies applied when the input signal is zero. This difference can generate an output voltage amplified by the amplifier's gain, so capable of affecting the expected results. And Italy allow offset is desired to reduce the possibility of producing an undesired output. Okay, the offset of an operational amplifier, like the 741 in this case, refers to the input offset voltage, and it's an important how to say parameter to consider in precision application. Um, Now, what is an input offset voltage? Okay, easy. The input offset voltage is a small difference in voltage that must be applied between the inverting and non-inverting inputs of the operational amplifier, 741 in this case, to make the output zero. In other words, it's an unwanted derivation in the output signal when the input theoretically should be zero. I want to explain you what is an offset compensation. So many operational amplifier, including the 741, allow offset compensation using an external way potentiometer connected to the offset null pins. By adjusting some this potentiometer, the input offset can voltage be minimized. So now, um, why it's importance of the offset. So in applications where we want to know how high precision is required, a high offset value can be problematic as it introduces error in the output signals. In such cases, it may be preferable to use an operational amplifier with a lower one input offset voltage source at the 0P07 of the LT110 instead of the 741 amplifier.
So now we're going to talk about the output short circuit current. This is a crucial parameter in operational amplifier like the LM741. This specification indicates the maximum current the op-amp can supply when its output is directly shorted to the ground. So for the LM741, the typical short current is range about from 25 milliamperes. This depending on the supply voltage and operating conditions, but that's what the datasheet says. So when an output is shorter, it creates a low impedance path, leading the op-amp to supply as much current as it can. So the LM741 is designed to be robust, handles these conditions relatively well by limiting the current to a safe range. However, it is important to remember that prolonged short circuits, especially at high supply voltage, can cause the device to overheat, potentially damaging it over time. So one of the advantages of the LM741 is that it includes internal current limiting, which helps protect the op-amp in scenarios where an accidentally um, might occur a short circuit. And this feature is particularly useful in a practical applications where the circuit might be exposed to unexpected conditions like in the laboratories. So in summary, the output short circuit current is a vital parameter that ensures the LM741 can safely handle accidental short circuits by limiting the current it outputs, preventing potential damage, and maintaining the operational amplifier relatively in various applications. We have gain. Gain is one of the most critical parameters for any amplifier, and we can find it in the datasheet as large signal voltage gain. And in normal conditions, gain it's around 200 volts per millivolts, and this high gains is what allows the op-amp to amplify even small input signal to a much larger output signal. And the gain can be calculated by this equation where A is gain and the gain of the system is determined by the feedback resistor and input resistor connected to the inverting input.
First of all, we need to know what is a CMRR. This is a measure of amplifier's ability to reject signals that are present or both input terminals simultaneously, known as common mode signals. The higher CMRR, the more effective it is at ignoring common mode signals and only amplifying the difference in signals between its non-inverting and inverting inputs. The CMRR it's a key parameter in operational amplifiers such as the OPAM 741. It refers to the amplifier's ability to reject signals that are common to both inputs, inverting and non-inverting, and amplifying only the difference between them. Technically, the CMRR is defined as the ratio between the differential gain, the gain for the voltage difference between the two inputs, and the common mode gain, the gain for the common voltage present in both inputs. It represents in decibels, dB. A high CMRR is desirable because it means the operational amplifier is more effective at ignoring noise or interference signals present at both. In a similar way, at the focusing on amplifying only the differential signal that needs to be measured for to be processed. In the specific case of the 741 operational amplifier, the typical CMRR it's in the range of 70 and 90 decibels or dB. This means it is capable of significantly rejecting common mode signals, which is crucial for amplifications requiring high precision, such as instrumentation and measuring systems. Now, in reference to the output voltage swing, the output voltage swing of an operational amplifier, like 741, refers to the range of voltage that the output can reach relative to the power supply rails. BCC plus and BCC minus, it's an important parameter because it indicates how close the op-amp 741 can operate to the supply voltage without saturing or distorting the output signal. Output voltage swing specifications of the 741. According to the typical 741 datasheet, the output voltage swing that the following characteristics. Um, in the number one, it's the dual supply, like 15 volts and minus 15 volts negative. The output with no load, the output can typically vary between approximately 12 volts and minus 12 volts. This means we're in a drop of maybe about 3 volts from the supply rails. And the second one is the outputs with resistive load. In this case, 2k ohms. The output can vary between approximately 10 volts and minus negative 10 volts. And okay, the second parameter is the single supply into 0 volts and 15 volts. The output range might be limited between approximately 3 volts and maybe 12 volts. This means it cannot reach either 0 volts or 15 volts in this case, due to design limitations. And okay, what about some importance of output voltage swings? Okay, it's similar to the before that, the output voltage swing is crucial in implications where a full output range is dedicated and needed, such as in audio amplifiers or signals processing circuits. Okay, now the limitation of the output swing means that the 741 cannot or is not suitable for applications requiring an op-amp with a full rail-to-rail output range, which is an output range that closely approaches or maybe approaches the supply rails. And in applications requiring a higher output swing or performance closer to the supply rails, it may a recommendation to better to use a modern one or pump designed with the rail-to-rail capabilities. And this is all. Talking about the PSRR, this indicates the ability of an amplifier to reject variations in the positive or negative power supply of the amplifier in such a way that it does not affect the output result. Finally, therefore, a high PSRR for the LM741 would indicate that it's less sensitive to fluctuations in the power supply applied. The PSRR, it's a measure of how well in an operational amplifier can minimize the impact of variations in the supply voltage on the output. It's like a key specification, especially in applications where power supplies may not be perfectly stable. Okay, the PSRR of the 741, according to its datasheet, the typical specification of the 741 personal amplifier, the PSRR, has the following characteristics. The first one is the typical value. Okay, the typical value of PSRR of the 741 is around 86 decibels. That means the amplifier can effectively reject fluctuations in the power supply voltage. The second specification and the second characteristic is the frequency range. The frequency range in PSRR is generally specific or specified for low frequency, like decibels, and may decrease at higher frequencies. And the third one, and finally, it's a PSRR of 86 decibels, mean that there are one volt variation in the power supply to the op-amp output, and will change approximately about 20 microvolts, depending on the context and the frequency of that. And now the importance of that of the PSRR, it's a high PSRR value. It's crucial in situations where, for example, noisy or fluctuations power supplies are used as it helps maintaining the stability of the output signal for more precision application of where high signal integrity is expected. And the OPAM's PCRR, it's an important consideration. In general, the 741's PSRR it's adequate for a lot of many common applications, although for applications require even great rejections of power supply noise. An operational amplifier with a higher one, PSRR, may be more suitable. And for example, according to this datasheet found, the minimum PSRR it's involved to 86 decibels, and typically it's like 96 decibels. And the parameter found of the supply voltage rejection radio, it's for 5 volts to uh, 20 volts. I think this is all for that.
We have power consumption and supply current. The power consumption of an op-amp is directly related to the supply current it draws. So as we can see in the datasheet, the supply current the LM741 typically consumes is about 1.7 milliamperes when this is operating with a plus minus 15 volt supply, which translates to a power consumption of approximately 15 milliwatts. This makes it suitable for a wide range of low power applications. Now to verify the information we had on the lesson and provided by the datasheet, we simulate the gain and another parameters in multisim. For the gain, we were used a feedback resistor of 10 kiloohms and one of the 2 kiloohms. This with an input voltage of 1 volt. So if we base on the gain equation, this must be 6 volts. So as we can see on in the graph of the simulation, we had a channel A that is our output, and we can see this is 5.99 volts. This means the information provided by the author in the datasheet and all the information we collect on this lesson, it's correct.
Now I want to tell you about the simulation of the CMRR. Here you can see the whole simulation of the gain. As all we know, the CMRR will be calculated with the gain simulation and the corresponding value, but you need to simulate by separate. And the calculation gives us the CMRR. If you pay attention, the result is 89.74 decibels, and in the 741 datasheet mentioned the range is about 80 and 90. So the conclusion means the simulation is correct, and the comproval of that is the calculation sample showed in the screen. Finally, about the simulation of the offset, all to say it that's happened exactly as the CMRR. So the simulations, it's quite similar, but in this case, with the multimeter tool, the program can show us the voltage value, and it's evident that the result is 1 millivolt. If we compare that with the datasheet information, we can see the corresponding value effective needs to be 1 millivolt. So the multimeter tool show us 1 millivolt and the datasheet needs to be 1 millivolt. In conclusion, the simulation it's correct.
So finally, as a conclusion, we can say the understanding the critical performance parameters of the LM741 operational amplifier or any operational amplifier is essential for effective designing and troubleshooting analog circuits. These parameters such as offset voltage, power consumption, CMRR, PSRR, gain, and output short circuit current provide crucial insights into the op-amp's behavior under various conditions. So by thoroughly grasping these specifications, engineers can optimize their designs for stability, accuracy, and efficiency, ensuring that the LM741 performs reliably in their specific application. So whether you're dealing with signal amplification, filtering, or other analog processing tasks, a deep understanding of these parameters will enable you to make informed design decisions and ultimately leading to more robust and precise electronic systems um, that make you a better engineer. So thank you all for watching this video lesson on the LM741 operational amplifier. Um, your time and attention are truly appreciated, and we hope you will like it and enjoy it. And understanding these critical performance parameters, it's not just about mastering the technical details, it's about building the foundation for your work as bioengineering. So whether your design is, we hope this lesson has provided valuable insights that will enhance your skills and contribute to your future success. So, thank you.